This video is going to be really fast, and in it we are going to figure out if you have a line segment, how do you find the middle of it or the midpoint of it. Think about it like this. To get from, let's say you start over here at x1, y1, and you want to get to x2, y2. One way you can think about it is that you can just take a bunch of stairs and walk all the way along these stairs to get from one to the other. Now, it doesn't really matter how many stairs there are, as long as you start at x1, y1 and end up at x2, y2. So, you could take a bunch of little ones like that, or you could take one giant staircase, in theory, if you walk all the way over and then go all the way up. But let's suppose that the staircase that you want to build to get from one to the other is like so. You go exactly halfway across, then you go up, then you go the remaining half and up. That should work, right? The nice thing about this is that you actually drew a couple right triangles. We could look at the biggest one and then also this first small one here. This one is also a right triangle, although we're not going to use that one, but it definitely would be a right triangle. Take a look at this. Since we kind of decided, hey, this first one is halfway, then I know that this distance right here and this one are the same. I also know that this distance right here, call it A. Oops, let's actually write this out. Sorry. We know that the entire distance, I'm going to scooch this over, sorry. x1, y1. We know that this entire distance is x2 minus x1. Since we defined this first step in our staircase to be only half the distance, then we know that this right here has to be x2 minus x1 divided by 2. Okay, let's take a look at these right triangles first, though. Oh, I say first, even though we just kind of looked at the distances there. These two right triangles should actually be similar, because since these are both perpendicular to the same line, this one and this one, we know that we have corresponding angles right here and right here. And we've seen this before, where if you draw a triangle and you draw a line, a new line, that passes through two of the sides and is perpendicular to the third side, then you actually have similar triangles. So I'll draw the smaller one right here. Oops. I'm going to separate them. The smaller one's right here, and the bigger one is right here. Again, this distance right here on the big triangle, x2 minus x1. On the smaller triangle, x2 minus x1 over 2. And again, we know that they are similar by angle, if anything. But there's also that theorem, although I forget the name at the moment. So I'll just say they're congruent by angle. Now, since we know that they're similar, we can take a look at just these two sides to get that scale factor. The scale factor right here. So the scale factor would be k, and I'm going to say k is the small one over the big one, would be x2 minus x1 over 2, that's just the small side, divided by x2 minus x1. The convenient thing about this is that, hey, I could divide top and bottom by x2 minus x1, and so my scale factor is actually just 1/2. This is really handy, because now we know that this distance right here, which I'm just going to call d for now, although we do know exactly what it is using the distance formula, this length right here is actually half the distance. And if that's half, then the remaining piece must also be half, d over 2. What the heck does that mean? Well, now what we did, since this magical purple point right there splits that red distance, that red length, into equal parts, that itself must be the midpoint. So where is the midpoint then? Like, what are its actual coordinates? Well, we could take a look at here. Essentially what we have is that it is starting from the x1, y1 point, you simply go over in the x direction this much, highlighted in green. And likewise, you're going to move up the y distance. How much? Well, we have to figure that part out. But since we know that we already have similar triangles, this vertical, the original vertical distance, again, this would be the distance the entire way, would be y2 minus y1, which would mean that this one down here, the smaller one, would just be half of that, y2 minus y1 over 2. And so really, what I'm getting at is to get from x1, y1 to the midpoint, call it MP, you simply add this much to the x coordinate, x2 minus x1 over 2 to the x coordinate, which is x1, that's what you started at, and y2 minus y1 over 2 to the original y coordinate, that's what you started. What will this be? Well, let's actually work this out. So if I have x1 plus x2 minus x1 over 2, and similarly I'll work out the y1, y2 minus y1 over 2. Well, let's get a common denominator here. So this will just be 2 over 2 y1, or x1, and 2 over 2 y1. Because now you can see how many x1s do I actually have on top now? Well, I really only have one, because I'll have 2 x1s minus 1. So I'll have x1 plus x2 over 2, and then down here I'll have y2, plus y1 over 2. So the midpoint of this segment, the midpoint of the segment with endpoints, x1, y1, and x2, y2, is this point, x1 plus x2 over 2, comma, y1 plus y2 over 2. You might notice that these two numbers right here, those actual coordinates, when you add two numbers and then divide by 2, you're actually finding the average or the middle of them. So that, in theory, just makes sense from your gut. Because when I say, if I want to find the middle of these 2 points, I could just find the middle of the x coordinate and the y coordinate, and that's exactly what you're doing right here.